And now to talk about finding the domains of these graphs. So for f plus g of a, f of minus g of a, f times g of a, or f divided by g of a, we must know that f of a and g of a exist. That means e must be in the domain of both of those functions. So if we are given f is going to be 3 over x plus 1, and we got g is x minus 2, we want to know what are the domains of all these following combinations of functions. So first thing we're going to talk about is really just the domain of f. So notice we got that rational there, so we got an x plus 1 here on the bottom. So we got to figure out when is that equal to 0. Well, that happens when x is negative 1. So we know that the domain here is going to be all x, with the exception that x cannot be negative 1. Well, if we look at the domain of g, there's not really anything that's stopping this one because we don't have a square root and we do not have a fraction bar or anything like that. So we don't have this rational function. So this here doesn't matter what x is. We always are going to output something. We don't have a spot where it's undefined. So this one has a domain where it's going to be any real number. So the only thing we really have to worry about is when x is equal to negative 1. So what that means is if I add these two functions, the only thing we have to worry about, once again, is just when this denominator is going to be equal to 0. And we already found that out. It's already going to be it's the only place we have to worry about is when x is negative 1. So we just make sure that's not in our domain. The same thing for doing subtraction. If I'm subtracting, the only thing I'm worrying about is this denominator. So you see kind of what we're doing is we're just mirroring those two domains together. If something doesn't work in one of them, it's not going to work in the new function. So anything that is undefined for f or g is undefined in the following combinations. So we're calling these combinations of functions. So here, 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 here. We're going to see that the only thing that we really need to worry about is just when that denominator is going to be equal to 0. And like I said, we already figured that out for f. So all we're getting here is we're just getting that same domain over and over again of f, because f is the only thing we had a restriction on. G was fine. So I think we know where this is going. If I multiply, I still have to worry about that denominator. And then this is in a slightly different color. This is the only place that we're going to have something that's really going to change for us. So you notice all these domains are the same with the exception of the division. Because we already have this part here, and then now I'm going to divide by an x minus 2. So from here, we said that x cannot be negative 1 because it's undefined. But now we're also dividing by an x minus 2. So where this would be 0 would be when x is equal to 2. So we have two places we have to remove from the domain. So the only time that you have to think about an extra point to get rid of or anything like that is in the case of division. Because we have to worry about what we take out because of F and G. Then we have to worry about where G is 0. So like I said, what we're looking for is just those places that's going to make that denominator 0. That's a place that we have to remove. So this is very similar to the problem you had before. Figure out what your domain is for F and G, and then you're going to go and figure out the domains for the rest of these. Right. And you don't have to write the equation each time. If it helps you, do it. If you don't need it, that's fine. All right. So the domain of F, we have to worry about where 2x plus 1 was equal to 0. So the only place that was going to happen was if x is -1/2. So my domain of F is everything except x is equal to 1/2. G, like I said, I don't have anything I'm dividing by. I don't have a square root. This domain is going to be all real numbers. So what I know here without having to show, like I said, I don't have to make my new equation for you. But what I do know here is that the domain would have to be, well, everything works for G, and the only thing that doesn't work for F is this -1/2. So everything should work except that -1/2. Let me show you what your function would be down here. Like I said, if we brought out the equation, we'd see that same thing. It's the only place you have to worry about is that denominator. B is a similar thing. The only thing I'd have to worry about is that G's defined every place. I only have to take out the one place that F's not defined because that's not going to work in my new function. Oops, not. So in this case, you'd have the same thing. X can be anything but -1/2. So here we get, this would be 3x plus 2 minus -2 over 2x plus 1. So we're only worrying about that denominator again, which is why we're only worried about that -1/2. For C, we'll see C for last. Let's do D. D is the same thing. We're doing that multiplication. The only thing we have to worry about is just that one point where F was undefined. I wrote that backwards, sorry. But what we have here is that F would be your -2 over 2x plus 1 times 3x plus 2. And we only have to worry about that denominator. So I'm not closing this out, but F was the one where we had division, so I have to worry about when G is 0. So when that would happen is we just take 3x plus 2. Let's figure out when it's equal to 0. That'd be -2/3. So technically I should wrote the 2/3 first, but we're not going to worry about that quite yet. But that means I have to worry about the point where F is undefined, and I have to worry about where the denominator is 0 of my new function, which is where G is 0. So that was all without actually having to give you the new function. But if I gave you the new function, it's going to be -2, 2x plus 1 over 3x plus 2. And just as a little bonus part here, had I instead gave you G of F, then I would have to worry about where F of X is equal to 0. So we're trying not to give you this one, but this one you don't have to worry about it. This case, you'd have to worry about where the top would ever equal 0. This is never 0. So this function is never going to be 0 no matter what we do. So in that case, if we're talking about the domain of G over F, then we're still just going to worry about that spot here where we're undefined. But in that case, like I said, F can be undefined, but F's not going to be 0. So we still just take out that undefined point. We don't worry about where the denominator is 0 because it's never going to be 0.